More specifically, we're going to talk about two use cases in a keychain, which are not usually widely used. It's a keychain sharing and the biometrics. So let's recap a bit what keychain is. And the keychain is a storage for sensitive data. It provides encryption and decryption on the fly for you, so you don't have to handle that. And it's a C-based API and is based on the same foundation as core data. It's based on a SQLite, backed by the same technology, very fast. And it's well integrated with the rest of the system. For example, with the biometrics, with the application security groups, and pretty much with Swift, Objective-C, you can use any programming language to access Keychain. And the Keychain architecture looks like that. So it's basically a C-based API, and you can store a lot of things there. For example, passwords or certificates. You can store keys or, well, pretty much whatever you like. And what we are going to focus on is this C-based API. So usually the API is quite clunky, and probably very little people actually use Keychain directly. Most of them use some sort of a wrappers. So let's take a look at the API a bit more in detail. And this is actually an example, a real Keychain call, and it doesn't look so simple anymore. Yeah, obviously it's very complex. And the reason for this complexity is that the Keychain is based on the procedural programming language C, and there are pros and cons to that decision. So the cons is that it's a very low level. And there is no too little encapsulation, and it takes a lot of repetitive code to write, and no predefined data types, no return type. You have to pass around dictionaries or similar structures to get data in and out. But on the other hand, there are a lot of benefits to this design, even though it might sound like there are none. It's very flexible because you can use it in Swift, Objective-C, C++, any other language that you can compile on Apple ecosystem. You can actually use Keychain add. And you can create bindings to other programming paradigms, for example, to object-oriented or functional, or if you want to stay in C land, you can use the C bindings and just be done with it. And you can tailor it very specifically for a specific domain, for a specific app that you are having, so that it's doing exactly the job you want. So usually there are a lot of wrappers around, and those are just a few of them. But if you look at the GitHub, there are really at least 50 implementations, and each of them doing a slightly different job. And today we're going to build the 51st. It's not that difficult, to be honest. So yeah, let's go back. Let's go back to this API example, and we can break down this API on three pieces. So first one is the query configuration. As you can see, there is a lot of data being passed into the query. We are preparing the query to be executed. Next one is query execution, and you have just a specific method call that does all the job. You just pass this data to it, and you get the result. And next one is the result handling. You try to understand what happened, if the result has succeeded or not, and doing something else. For example, returning the value or showing an error to a user so that it can be handled. So, and let's zoom in on the step 2. As you can see, there are 3 parts of it. So we have the query input here. We pass it as the parameter because we configured the dictionary before. And we also have to pass the output as the parameter, as the reference to that parameter, because, as I said, it's not an object-oriented language. It's procedural. And what you get returned is actually a status code, whether your operation has succeeded or failed. And there is actually a website, OSStatus, because what gets returned is just a number, and you probably don't know what that means. And you can enter your number there and get the actual result. It will decipher it for you. So let's do that first. Let's fix this and get the proper error in our programming environment first. We're creating the extension that will do another method call to the security framework and extract the proper description of that error. And next step is storing the data. And let's think a bit of how Keychain is actually designed. So at the top you have the Keychain, which is the, let's say, an entity to store the data. The Keychain is actually global across the whole operating system, and it uses segregation to store data for individual applications. And then you have so-called services. One Keychain might store multiple services, essentially like a name for your group of data. And each service has some data items in it, Keychain items, like passwords, certificates, and so forth. For example, we can name the service to be local, and there could be a password and a token and some other items in it. And one of the problems is that you have to include the name of the service with each Keychain request, as I shown before. So next step, let's fix that one. We create a class, and that class will be initialized with the name of the service, so that we can then pass that class around and do not remember the actual name of the service we used to configure. And yeah, then we need to build this query and provide it into a class. So we just embed the name of the service into the query. Again, a very procedural manner. You have to, if the name is provided, you just use some specific constant and set it there to your query. I guess if the name is not provided, then it will use some default keychain, default service. And now let's build, based on that base query, a removal request. So to remove a key, we need basically a key as the parameter. And we use that base query to build on top of that. So the base query contains the service name, for example, and we add the account. In this case, the account will be the key. And then we use our make an error function to verify that there is no errors. If there is an error, we throw an error. And just do nothing. It's a void function. We continue. So again, we use the same base query, and there is one method called this procedural method call. Setting data is pretty much similar. We use our remove function, which we built before, and again continue with the base query and use an add method to add the data. And basically the rest of it is the same. So we use the same pattern to handle the error, and we use the base query. We set some parameters there, like a key and value, and call the function. So this way we create a wrapper, an object-oriented wrapper around the procedural core of the keychain. Getting data is actually the most complex one, but under the hood it follows the same pattern. You have the base query there, and you have to figure out what kind of data you would like to be returned. For example, this is the return data means that you have to return the data, because sometimes you might want to call the keychain without actually returning the data. And use the same base query and the same method call. And so far, this looks good. We got delete, set, and get data. But so far, we were able to only get the data types. How about the string, the integer, maybe Boolean types? How about those? And the answer is, of course, as we've done before, you have to build on top of data. So yeah, for example, a string type, you use the string and you use the data and you decode it with your specific encoding. In this case, it's UTF-8, but you can use whatever you want. So the keychain is very flexible in the way you store because you have to design your whole core around only ability to store the data. For example, in the way I designed the keychain framework, I use the NS-string, NS-number to get the other types, for example, integers and booleans. But there could be a different type of encoding. For example, the codable and decodable, you can store JSON this way. There is no really limits for the data you can store. Yeah, that way we basically build keychain from scratch. It's not that difficult. Now let's move to more advanced use cases, a biometric use case. So the question is, how would you detect a change in biometric state? For example, when you have a new finger enrolled on a phone, so you had one finger enrolled and you added another one, or you enrolled a different face, different appearance in your Face ID system, or you even deleted all of the faces and Touch ID signatures. How would you detect that on the app side? Normally, the local authentication framework provides you with a so-called state. So you execute the command, can evaluate policy, and you get the data value so-called state. And if that state changes across the application launches, then, or across policy evaluations, you know that that something in your biometric configuration is changed. You don't know what it is, but you know that it's no longer there. And let's take a look how it works. So let's imagine you have an app and you get the state. That's basically some sort of data value like that. And you get, at some point in runtime of the app, of course, you persist that value, and then you might try to call the same can evaluate policy method and see if this value has changed. At some point in the app, it's different. You know that it's changed. So that's pretty easy. But the problem is that it's not matching across multiple apps. So if you have two apps belonging to the same developer, and you would like to enroll your biometry only in one of those apps, and reuse across all of them, that wouldn't work. And most importantly, it's not even shared across the app IDs. Oh, sorry, it's not even shared across the app extensions. So almost app extension has a different app ID, and in a sense, it's a different app. So you will not be able to detect the biometric changed reliably only in one of those modules. So they will behave separately. So if the biometric changed in the app, you will get the same message in the app extension. You will have to, and the data between them is also different. So the values are not matching between the same app and the app extensions. So the keychain helps us in this case, and the way you work around this issue is that you use Biometry-Protected Keychain. And one of the benefits of it is that the application code doesn't even have an access to the data it's stored in the keychain if the biometric has been authenticated. So if the user can authenticate with a Face ID or Touch ID, then it wouldn't be possible to even retrieve the data. And one of the benefits is that the values are completely erased if something changed in the biometric signature. For example, if a different finger is enrolled, or an appearance is changed, and so forth, or the biometric authentication has been disabled completely and re-enabled later on. So you can really reliably detect a change in the biometric method. And of course, since you're sharing the data across multiple keychains, across multiple apps, that will be also reflected across all of those apps. So again, we go back to the procedural code, and to mark an item that we're going to store as biometrically protected, we have to append this special attribute. And more specifically, it's this one. for example, attribute accessible when unlocked this device only. But there are different ones. You can use the ones that the device has to have a passcode installed or unlocked only once and then across the launch of the device. And then you use this in your methods, essentially demanding that this item that you want to retrieve is the biometrically protected, and you will have to provide the context, the biometric context, to retrieve the data from it. And now let's talk about the keychain sharing. So I've shown before this this chart or schema where you have the keychain, multiple items, and the services. But in reality, the design is actually looking something like that, where you have multiple apps and they can share a single keychain and pass data around. So for example, if you enter the password and store the password in one app or application extension, you will be able to retrieve it in some other app. And if you change, for example, biometric state in one app, the app extension immediately knows that the change has happened, and it will not grant an access to the data. So this is how everything looks without the sharing. And to enable sharing, we just add the application security group in Xcode. This is slightly different than the keychain group. You can use any of those. So either as here shown the keychain group, or you can use the application security group. That's a bit bigger term. It encapsulates also file sharing, so you can share not only the keychains, but actually files. And after you do that, you can mark some items as shared. Some of the items will not be shared as you wish. And that's how you pass data around. And the use case for that is, for example, is storing and retrieving the biometric statuses and the passwords in the application extension. For example, autofill extension, but you can protect any other app extension, like a photo sharing extension, by the biometric. But you have to enroll it only once, and that could happen either inside the extension or inside the app. From the code perspective, it's also pretty easy. You have to remember the app group that you have assigned to the keychain in the variable, and then you just use it in the same base query that we've seen before. Yeah, so you just augment the base query with the application group, and now all of your items, all of your set and get requests will be routed to the specific app group. So yeah, the conclusion is the Keychain has a very powerful API, very flexible API, and it's too low level, of course. So if Keychain Wrappers don't work, you have to make your own, but in 90% of the cases, you can go with a wrapper, and that will pretty much solve your problem. So now let's go to a quick Q&A, and for the most interesting questions, we'll have a few gifts there, and what you see on this screen is actually completely designed by me. So if you want, you can design this thing the way you want. The only requirement for the keychain is that you store data. Everything that can be converted to data, you can design the API the way you want. And that's basically the main point of my talk. If you need some application-specific logic, you can design it for your application. I found this the simplest design, and in fact, of course, there might be some legacy reasons, for example, compatibility with other solutions that you've used before. But this is actually, if I were to design this from scratch, I'd probably use the same approach. So why I wouldn't use the generic here is because there need to be some logic that detects what kind of type you're requesting, and it has to be somewhere. So if you were to write this as a generic function, you have to check if this Boolean, and then you call the bool value method, then you call integer value methods or double value. So yeah, it's possible to design it with generic, but pretty much all the architecture has to change a bit. So let's take a look a bit here, and this is how we get the string. So the string is just a UTF-encoded data string, and you can probably change something how you encode the data in general. Maybe you can use codable here, and that's basically the answer of your question. Then you don't even need to convert everything through the string. But in this implementation, everything goes through a string at some point, except data. It's an excellent question.
I don't think so.
Yeah, it is. Because the first reason why it is excellent is because actually, I think 80% of the actual implementation is not shown on the screen. So a little bit probably exaggerated. It's simple. There are a lot of small things going on under the hood, like locking and unlocking the whole keychain so that you don't get the concurrent access for writes, because it's the, as I mentioned, it's a procedural language, C, and you cannot sort of figure out if it's the same thing calling it or a different one from the API perspective. So the first thing you, but more importantly is that the way, for example, the biometry behaves is very different on Mac and on iOS, and then the way on Mac you might have LA context being passed from a different process and so forth. So there are lots of differences in the platforms. That's the first thing. And yeah, the way to go about testing all those differences, I think, is first of all is to create some sort of mock keychain that will do all of that implementation. So you can test actually if the application code is calling the right methods. That's the first thing. And then so far in my experience, actually, the troubleshooting keychain might be very difficult because, as I mentioned, the error codes are very, let's say, difficult to understand. And there are lots of things that might go wrong. For example, you might have a different error on the simulator versus device. So a lot of it is just a manual testing and debugging. But a lot further can be prevented with using mocks and so forth.
Good answer.
Thanks. Yeah, I think the simple way is to, it's not actually a keychain question, but more like a dependency management question. So from my perspective, what I would do is to have a same package, same keychain package, updated across the apps. So both apps use the same package. So there would be no divergence in encoding, right? And whatever pushes to keychain, whatever works with that keychain and stores that token also has to be shared. So that encoding algorithm. So that way you kind of limit yourself from that problem because you will never have two different implementations. So that's one of the solutions for that. But if you, let's say, have a different implementation in the previous version of the app, let's say you want to change encoding, the way to do it is migration, and there's no like an easy answer for that, in my opinion. You have to migrate the data on install and keep that for some time before those versions go obsolete. Or, which is even more dangerous, is you want to redesign your new keychain or new storage algorithm with respect to the data that has been stored for some time there. This is very limiting, so I'm not recommending to do that. I always prefer to redesign from scratch and to use all the best knowledge to have a new design. But sometimes you have to respect the previous implementation and keep full compatibility with it for some time. Depends on the application. So if the security is the first purpose of the app, is the main goal, and if you want to have something tailored specifically, like in this app, for example, we wanted to have a very controlled flow, what is not available on your classic Keychain Wrappers. They simply do not allow that kind of interaction where you can unlock the biometric authentication at one part of the app and then pass it around at some further point so that you don't have to show the biometric pop-up again and again over the course of using Keychain. Then, of course, you can have your custom implementation. But if you want something basic, you just want to guarantee that the data is stored securely, then you can just use the wrapper off the shelf. So it depends on your goal. And usually I recommend using the wrapper off the shelf because it's very difficult compared to just using the wrapper to write this code. As we've seen, this is not really a beginner level code, to be honest. This is like this is not the full query, of course. There are a lot of stuff going on before and after it, so which is not even shown here. This is more like a conceptual overview, so it's not so easy.
Do you have to access it on the main thread, or
You
you have to just make sure that you have exclusive access? No matter what thread you access on, but you have to manually like lock it.
Yeah. So you can have that locking embedded so that you can access it in different threads.
Like you could wrap it in an actor.
Sorry?
You could wrap it in an actor if you wanted to get all fancy.
That should work actually, yeah.
Okay.
That should work. So that's actually the beauty of this custom design, that you can have whatever design you want. You can have functional, object-oriented, or like actor-oriented, whatever you want, because everything below that is a basic C calls.
Cool. Thanks a lot. Great.
Yep.
Thanks, Richard.
So I would like to give some gifts for the best questions, and